What we have here is one of those photoelectric cells that switch on some device. In this case, I think this was plugged into one of the landscape transformers, so that would have been a 600 watt. Of course, this is saying 2000 watts, 1800 with a ballast, which I would expect that's what we cater for a landscape transformer, something that's inductive, and I guess this is just resistive load. So again, this is a 240 volt system, well 280 to 277, which means really made for the American system, but will work for 240, 50, 60 hertz. Allow 1 minute for response, and then what we have is the typical American colors: neutral, load, and then switch load. This is all heat shrunk and plugged in at the end. And again, what we have is an adjustable screw here, so this thing moves relative to that, so you can adjust it to point towards the source of light. That is a cell there. I would assume cadmium sulphide. If I'm wrong on that, I'll put it down in the description. It looks like it's sealed, so it looks like the best way to do it is to cut here. So let's open it, let's see what's inside. It's a little simpler than I expected. I expected a relay, I expected a resistor, the photocell, cadmium sulphide cell, and that would have pulled in the relay. It's similar concept, but it appears that this is using something like a bimetallic strip here with an adjustment here. And what's happening is essentially power comes in here, goes onto this, goes onto that contact there, the first contact, and it goes also across through these rivets onto this strip. Power comes the neutral here, so it completes the circuit through the photoresistor, through the resistor, and essentially you'll get a low power flow because this resistance will be high when there's no light source here. Once there's light source here, the resistance drops, the current will increase, this will then deflect, and if it deflects, you'll probably hear it. Let me see if I can press it with one hand. You can hear it. Maybe you can see it also, but the contacts separated. Yep, it's visible on the video. So this deflects and separates the power from this. So when it's dark, not enough power, not enough deflection, those two contacts are made. Once there's enough light and there's enough current flowing through this, it deflects and disconnects. That means this uses power all the time. I don't know how much power. We could try to check the resistance and see if you can work that out. And just to show how this works, what I'll do is I'll connect it up with the meter and show that actually when you press, power comes off the red. So this is all connected up now. As you can see, we have one on the red, one on the black, and it's going to the meter. The meter is beeping. If I press this, it comes off. So as soon as this deflects, it will take off the circuit. So let's check the resistance of the entire thing with and without light, and apart from that, there's not that much else to see. So combined, we're looking at 0.39 mega ohms, 0.4 mega ohms. That is with light on it. This is about 5.6, and I guess the rest is that. So mostly it is the photocell that has the high resistance, and if I put my finger over it, we had almost 7.6, so a significant increase. 0.4 to practically 0.7, that's 700 kilo ohms. That means practically zero flow even at 240 volts. So the power drain on this was probably quite minimal. I can calculate it up, but I mean, if you're talking about 40 kilo ohms, yeah, 240 volts, that's going to be a negligible amount of current.